We will demonstrate a large number of cases to explain the handling methods for different types of Module 190 malfunctions. In the system explanation video, damaged LBA entries include structural damage that prevents 190 from expanding, or damaged entries displayed in red when expanded using the default method, or the presence of numerous empty entries displayed in yellow when expanded, as well as the scenario of formatted 190. The demonstration is divided into two parts, damaged 190 and formatted 190. Please make sure to watch the aforementioned system explanation section repeatedly and then combine it with the case studies to understand the operational methods. We will demonstrate how to handle the damaged 190 module. In sequence, select the first 190 module. Expand using the default method and observe some red damaged entries. There are two entries with a starting LBA of 0. The first entry is marked in red. The second entry is marked in green. If the rebuilt entry with an LBA of 3488 is marked in green as the starting entry, it meets our expectations. After attempting method 1, only one entry is displayed, indicating a failed rebuild. Clicking OK will return the expanded results, and we will proceed with method 2. The starting entry aligns with our analysis. Re-expand the 190 module and manually select the first entry using method 1. Again, it reports a failure, and clicking OK will return the original entries. Reselect the entry and use method 2. It can be seen that manually selecting the entry did not take effect because error entries cannot expand to subsequent nodes. The program returns the default results of method 2, where manual selection does not work. Re-expand the 190 module and observe the entry with LBA 0 at 3488, using method 3. It can be seen that some entries are missing. This is because method 3 applies stricter filtering and may result in missing entries. Therefore, in the majority of cases, methods 1 and 2 cover a broader range of LBAs, while method 3 is often for experimentation. Re-expand the 190 module, since only the entry with LBA 0 obtained from method 2 meets our requirements. And there is only one such result. We only need to use method 2 for the rebuild, and there is no need to manually select the LBA 0 entry. Save it as a dump file and choose the T2 raw data method for expanding. If the 190 module has been cleared in last operation, only check the option for writing T2 during the first time. In sequence, select the second 190 module. Expand using the default method and observe a large number of red damaged entries. There are two entries with a starting LBA of 0. The first entry is green. The second entry is red. In theory, the result obtained without manual method should be based on the first entry. Additionally, the second entry with a starting LBA of 10,618 can be directly found on current page. Use method 1, and the result matches the expectation. Re-expand the 190 module and use method 2. The result matches the expectation. Re-expand the 190 module and use method 3. The result still matches the expectation. This indicates that the simpler the entry structure, the less difference there is among the three methods. Therefore, we can use method 1. Save as a dump file. Expand the dump file. The two options can refer to the previous answer. In sequence, select the third 190 module. Expand using the default method and observe that almost all entries are red damaged entries. Confirm the entries with a starting LBA of 0 1 by 1. The first entry is marked in red. The other entries with LBA 0 are also red damaged entries. There is a yellow marked entry with an LBA of 0 here, which can be ignored. Starting from 65534, we find a large number of different entries with LBA 0. Now we need to verify these entries. We need try to find the second entry that meets the starting LBA rule. The next starting LBA after 65,534 is 65,535. We can find it. The next starting LBA after 115,499 is 115,500. After searching, it cannot be found. The next starting LBA after 115,563 is 115,564. After searching, it cannot be found. The next starting LBA after 115,749 is 115,750. After searching, it cannot be found. From this inference, it appears that a large number of repeated damaged entries make it easier to find relatively complete LBA chains, while a single damaged entry may not lead to subsequent nodes. Using method 1, only 2 entries are obtained. Re-expand the 190 module and use method 2. All entries are yellow empty entries. Re-expand the 190 module and manually select the first LBA 0 entry, using method 1. This matches the result obtained from the default method 1. Re-expand the 190 module and manually select the first LBA 0 entry, using method 2. This matches the result obtained from the default method 2. Re-expand the 190 module and manually select the first LBA 0 entry, using method 3. Compared to method 2, LBA 0 entry is missing, while the rest are empty entries. This testing indicates that the default expanded entries are all invalid entries. At this point, it is necessary to check search for all nodes. There are 2 entries with a starting LBA of 0. We found that the entry with LBA 0 at 6406 is marked in green, while the other one is a yellow empty entry. Therefore, the only possible result for the rebuild is the one with LBA 0 at 6406. Let's confirm the second entry. We found that there is no entry with a starting LBA of 6407. Using method 1, we found that the program automatically filled in the entry for LBA 6407. With search for all nodes checked, using method 2, the result also includes the entry for LBA 6407. With search for all nodes checked, manually select any entry for 6406 and use method 2. The result is the same as the default method 1. We can conclude that the green entry with LBA 0 is the ideal one. If there is only one entry with LBA 0, there is no need for manual selection. We only need to consider using method 1 or method 2. Note, if there are no available entries in the default case, it is necessary to check search for all nodes. In this state, only method 1 or method 2 can be used. We use method 1. Save it as dump file 1. In the search state, use method 2. Save it as dump file 2. Observe the file sizes and find that there is a minimal difference. From here on, we only need to confirm the partitions and files separately. In sequence, select the fourth 190 module. Uncheck the Search for All Nodes option and expand using the default method. Encounter an error during the expansion process, and there is feedback in the log. At this point, it is necessary to check Search for All Nodes. Even with the option checked, the expansion still encounters an error. This indicates that the structure of the current 190 module is severely damaged. When both the default method and the Search for All Nodes method fail to expand, it is not possible to repair the data. In sequence, select the fifth 190 module. Uncheck the Search for All Nodes option and expand using the default method. Observe the entry markings. There are several green entries at the beginning, and the rest are mostly yellow empty entries. Using method 1. The results seem to be similar to the original entry structure. Re-expand the 190 module and use method 2. The entry structure is the same as before. Re-expand the 190 module and use method 3. Observe the entry structure, which is the same as the previously obtained results. This indicates that the default entries recognized by disk consist mostly of empty entries. And there are not many usable LBAs. At this point, it is necessary to check Search for All Nodes. Some LBA 0 entries can be found. The first LBA 0 entry has an ending LBA of 454. We found the second entry starting from LBA 455. The next LBA after 828 is 829, which can be found. The next LBA after 1027 is 1028, which can be found. The next entry after 28,669 can be found. The next entry after 29,100 cannot be found. In other words, there are 4 cases for LBA 0 entries. Using method 1, the result is the LBA 0 entry with an ending LBA of 454. The overall structure is similar to the result obtained without checking Search for All Nodes. In the search state, using method 2, the result is also the LBA 0 entry with an ending LBA of 454. Re-expand the 190 module, and this time manually select the LBA 0 entry for 828 and rebuild using method 1. Although we specified the entry to use, the overall structure still consists mostly of empty entries. Re-expand the 190 module and test the LBA 0 entry for 1027, using method 1 for rebuilding. The result is the same as the previously manually selected entry for 828. Re-expand the 190 module and test the LBA 0 entry for 28669, using method 1 for rebuilding. The result is the same as the previous 2 attempts. Based on the tests, we can provide a relatively reliable conclusion. When the results obtained using different LBA 0 entries are similar, meaning that the starting LBA 0 entry is different, but the overall structure is dominated by empty entries, we can be certain that the current 190 module is actually the result of multiple updates after data loss. In other words, when the 190 module is damaged and causes data loss, the more times the power is turned on, the more frequent the updates to the 190 module. Eventually, the original entries are replaced by the updates, and we can no longer find usable entries. Only the historical LBA chains left by the 190 updates remain. Therefore, no matter how we choose to rebuild the entries, the structure of the LBA chain will always have several normal entries at the beginning, and the rest will be mostly empty entries. This also suggests that the best choice is to back up the 190 module as soon as possible for processing and to avoid repeated power-on cycles. In sequence, select the sixth 190 module. Uncheck the Search for All Nodes option and expand using the default method. Found that there are no entries, indicating that the 190 structure is normal but without LBA records. Check the Search for All Nodes option. The entries are still empty. Here, I would like to introduce another mechanism of the 190 module. For hard drives with PCB number 810051, although the 190 module is necessary for drive recognition, it does not actually record LBA entries. Normally, T2 is not needed. Regarding the issue of 190 module damage, all we need to do is to empty 190 module and rebuild translator. So the sixth case of the 190 module belongs to the type with PCB number 810051. The seventh case has been demonstrated earlier, so let's directly select the eighth 190 module. Expand using the default method. LBA 0 entry has only one case, and the entry appears to be normal. Use method 1, save it as dump1 file. Expand using the default method and use method 2, then save it as dump2 file. Expand the T2 files separately. The size of the valid data is the same, indicating that the data results should be the same. We have demonstrated how to determine the usability of 190 entries under different scenarios, and how to rebuild using the manual selection method. Below we will discuss the scenario of formatting the 190 module. Expand the collected formatted 190 modules and select the first one. The entries obtained using the default method appear to be quite complete and normal. It is important to note that formatted 190 modules can only be handled by checking the Search for All Nodes option. Observe the LBA 0 entries. There are only 2 cases in total. Next, verify the second entry. We can find the entry for LBA 13320. The next LBA after 69,630 is 69,631. And we can also find the entry marked in green. Using method 1, the LBA 0 entry obtained is 13,319. Let's confirm the LBA 0 entry obtained by the default method. The LBA is 69630. When we check the Search for All Nodes option, the LBA 0 obtained by method 1 is 13,319. Combining the 2 LBA 0 cases we just found, we can confirm that since the default recognized LBA 0 entry after formatting is 69,630, searching for and using that entry to rebuild will definitely not recover the original user data. Therefore, the entry for 13320 obtained by method 1 must appear before the entry for 69630. The data recovery result can only be determined by the entry where 13320 is located. Under the search status, use method 2. The LBA 0 entry is the same as the result from method 1. So, we can directly choose either method 1 or method 2 for the reconstruction. We save the corresponding dump files separately. Then we expand the dump files separately. Confirm the size of the valid data. We can see that the sizes are similar, so we can verify the partition and file results separately. Decide which one to choose if the results are the same. Select the T2 with a larger valid data size for data imaging. In sequence, select the second formatted 190 module. The first few entries are green, while the rest are mostly yellow empty entries, and the last one is green. This is a typical structure of a formatted 190 module. The default LBA0 is 766,575. Check the Search for all nodes option. We can immediately see 2 available LBA0 entries, both marked in green. Further down, we can see other LBA0 entries. The first LBA0 is 65,534. The next LBA is 65535, but it was not found. The next LBA after 750,985 is 750,986. We can find the second entry. The next LBA after 750,1023 is 750,1024, and it can be found. The next LBA after 750,3327 is 750,3328, and it can be found. The next LBA is 766559. We can find 766560. Here we cancel the Search for all nodes option. The default LBA0 entry obtained is 766,575. When we find this entry, we need to skip it and try other entries for manual selection. The remaining entries can be compared using the same method as before. Using method 1, the obtained LBA0 entry is 65,034. There are only a few green entries, while the rest are empty entries. Let's review the default recognized LBA entries again. LBA0 entry is 766,575, which is different from the previous result. However, the structure is still the same, and it appears to be a formatted 190 structure. Let's expand the search nodes again and use method 2. We only get a few normal entries. Under the search status, check the second LBA0 entry and use method 1 to rebuild. The obtained entry structure is still similar to the formatted 190 structure. Under the search status, check the third LBA0 entry and use method 1 to rebuild. The obtained entry structure remains the same. Under the search status, check the fourth LBA0 entry and use method 1 to rebuild. The obtained entry structure remains the same. Under the search status, check the entry for 766559 and use method 1 to rebuild. The obtained entry structure still remains the same. Let's go back to the results obtained from the search method. One issue becomes apparent. No matter how LBA0 entry is manually selected, the result is only a few normal entries, while the rest are empty entries. This is highly similar to the structure of the default recognized formatted entries. In fact, it indicates that 766575 is the last updated LBA0 entry obtained from the 190 module. The other LBA0 entries are historical entries generated by the updates to the 190 module. Considering their nearly identical structure, it can be inferred that the other LBA0 entries were generated after the formatting occurred. As the entries were updated, the original LBA entries have gradually been replaced. Thus, the chances of data recovery are extremely low. This is similar to the demonstration of a certain type of 190 failure mentioned earlier. If the hard drive is powered on multiple times after a failure occurs, the 190 module will gradually overwrite the original entries. The amount of recoverable data will also decrease gradually until it becomes unrecoverable. According to the sequence, we select the next formatted 190 module. We cancel the search for nodes. The default expanded entries appear to be normal, with LBA0 as 3967. However, note that this is a formatted entry and cannot be used. We check the situation of the LBA0 entries by selecting the search for nodes. We find that only 3 cases are marked as normal: 934, 3967, and 65790. Note, 3967 is the default recognized LBA0 entry and cannot be used to reconstruct data. Using method 1, we obtain the LBA0 entry as 934. The overall structure appears to be normal, and we save it as dump1 file. Under the search status, we use method 2. The result is also the LBA chain where 934 is located. We expand searched results again. 3967 is the default LBA0 entry used and is an invalid entry. At this point, we need to manually select the entry for 65790 to test the result. We manually select 65790 and use method 1. We save it as dump2 file. Now we need to expand both files separately and compare the data sizes. We find that the sizes are consistent. Note, as mentioned earlier, the default recognized entries are based on 3967, and the structure appears to be normal. This suggests that there may be a significant amount of new data written after formatting. Otherwise, the formatted entries should primarily be empty entries. At the same time, the results of the 934 and 65,790 entries obtained through the search method show completely equal data sizes. If these 2 entries were generated before formatting, theoretically, with user operations and updates, it would be impossible for the data sizes to be equal and for no other historical LBA0 entries to be found. Based on this, it is more likely that these 2 LBA chains are entries generated after users formatted and wrote new data. The entry where 3967 is located represents the last update produced. Therefore, this 190 module cannot recover the portion of user data that has been overwritten by the entries. In sequence, we expand the next formatted 190 module. Here, there are multiple markers. Select Site0, but expanding fails. Select Site1, and we can find many entries. This indicates that the hard drive is using the entries where Site1 is located. We confirm that LBA0 is 51,455. Check Search for all nodes. Select Site0, but expanding fails. Select Site1 and find a large number of entries. We confirm the LBA0 entry and find that there are only 2 cases marked as normal. The next LBA after 3934 is 3935. We can observe the entries after that. There are numerous red damaged entries. We can find green normal entries with 3935 as the starting entry. Based on the previous analysis, the chances of data recovery are higher for the LBA chain where 3934 is located. Using method 1, it is indeed the LBA chain where the entry 3934 is located. Save it as dump1 file. Under the search status, select Cite1. Use method 2 and save it as dump2 file. Expand the dump files separately and compare the data sizes. Notice a significant difference in the data. If the results of partition expansion are different, choose the T2 file with more comprehensive partitions to extract data. If the results of partition expansion are the same, consider the T2 file with more data. If the partition cannot be expanded, choose the T2 file with larger data volume first, create an image, and then scan the data. Now let's review the 2 options. Whenever we clear the 190 module, we must select it once when uploading the T2 for the first time. From the second time onwards, there is no need to select it. Note, for some hard drives, including USB series, disabling the 190 update can cause copying and recognition abnormalities. For the first T2 operation, only select the translator regeneration option. If both options have already been selected, we can click on Enable HDD to update 190. Similarly, the option to disable HDD to update 190 can also be found here. We combine the previous explanation to answer question 8, power failure during copying. The first reason has already been mentioned. Some drives do not allow disabling the 190 update. Copying is prone to power failure issues, and the 190 update must be enabled. However, during copying, the 190 update may cause power failure again, resulting in ID recognition failure. We provide a complete process to address the issue of unrecognized state due to sudden power failure during copying. First, disable 411, power off. Re-identify to obtain the module list. Expand the 190 module using the ID method and select the 190 file that was cleared last time. Write by ID mode. Then, enable 411, power off. Re-identify to obtain the ID. Expand the process T2 dump file. Only select the translator regeneration option. Whether to disable the 190 update depends on whether there is a significant difference in the copying process before and after the disable. From the second time onwards, there is no need to select again when uploading T2. Below is the introduction of the second scenario regarding the power failure issue. Let's continue with the current formatted 190 module as an example. Under the search status, select Site1. We have already analyzed that the LBA0 entry of 3,934 is correct. Now let's count how many entries there are for 3,934. We found a total of 350 identical entries from 0 to 349. But are they really identical? Please pay attention to the data on the right side. Clicking on each entry one by one, we can clearly observe that the data on the right side keeps changing. In fact, for the same node, an infinite number of duplicate entries can be found. The reconstruction can only use the default algorithm to select one of them. This entry represents only one LBA range, which can be composed of many sub-entries. Having 350 duplicate entries means that there can be at least one combination and up to 350 combinations. However, accessing data on the hard drive clearly requires using only one specific combination. If the default algorithm selects an entry that deviates significantly, it may cause power failure during the copying process. In such cases, it is necessary to repeatedly upload T2 or skip current area to continue imaging the data. This into a single algorithm cannot perfectly solve this situation, and continuous improvements are needed in the future. The above content covers all the explanations regarding the 190 and T2 modules. The video provides detailed information. It is recommended to watch it repeatedly to grasp the complete technical methods. We can draw a simple conclusion. LBA0's entries, the more variations there are, the more it is necessary to use manual selection method to obtain as many LBA results as possible. Then, based on the effective data size and partition expansion results, a comprehensive judgment can be made to select the appropriate T2 dump image data. Note, when only some entries are damaged or the entry structure is intact in the default expansion, the reconstructed results obtained through the search method may not perfectly align with the original LBA entries. This is a normal phenomenon.